Right. So welcome back to lecture 7, and we begin this lecture by recapping on what we did in lecture 6. So this is what we obtained at the end of lecture 6. So now we are still dealing with our simple mechatronic system model of a rod attached to a motor, and now it's a combination of Simscape and Simulink blocks. On one side, you don't see any kind of math, and the other hand side, we see some math and math operation blocks. That is because at this moment we still are implementing the effects of gravity through the evaluation of expressions that we have specified. This too can be relegated to a ready to use block, a Simscape block, which will handle the math behind the curtains, and all we would have to worry is about making the proper connections between the blocks. So we'll be using a Simscape block set called IntroSimscapeMultibody in order for us to implement the rod, the revolute joint, and the effects of gravity. So basic components of Simscape multibody are bodies, assemblies, and dynamics. It would be easier for me to explain bodies and assemblies if I make the analogy to the SolidWorks parts and assemblies. Just like in SolidWorks, bodies are so just like in SolidWorks parts, bodies are solids, and in Simscape they can be either rigid or flexible, but still only solids. Assemblies in both cases are kind of extremely similar through the specification of constraints, uh, relative motion between multiple bodies are constrained in some, not constrained but restricted in some manner. When it comes to dynamics in multibody, you can specify the kinetics and ask multibody to calculate the kinematics, or it can be the other way around, or some combination of those two. So that's essentially what SSC multibody is. So let's take at how to implement models using multibody and what are the fundamentals we need to know before we jump into implementing models. So one of the foremost fundamentals we need to know is frames. Frames are associated with bodies. They are used to specify the location and the orientation of bodies, and frames consist of an origin and three principal axes. So that information will be sufficient for you to jump into modeling, and you will develop some intuition with regards to frames as you do modeling. And as you move on, take a look at the help page if you want some intricate information with regards to what actually frames are, how they are represented, and if you want information on operations which can be done on frames. I suggest that you do it hand in hand while you develop models. Right. Some You might be familiar with the solver configuration block. From lecture 4 onwards, as soon as we introduce our first Simscape block, we had to bring in the solver configuration block and connect it to our network. So it specifies parameters of the solver, but so far we haven't made any changes with regards to the parameters. We just left them at the default values. So in this lecture as well, we won't mess around with solver parameters. We will keep it at default values. And as before, we'll just bring it in, connect it to our network. But keep in mind, if you want to change, make changes to the solver for some reason, and you'll have to do this when at some point you build extremely complex systems, the changes can be done by double clicking on the solver and varying the parameters as you want. In addition to that, solver configuration, which is a compulsory block, references or reference frames are also compulsory blocks, regardless of whatever domain you are modeling using Simscape blocks. We dealt with Simscape electrical and Simscape mechanical rotational domains, and in electrical, our reference was a ground, electrical ground, or a position at which the potential is zero or the voltage is zero. And with regards to mechanical Simscape mechanical rotation, reference frame was a fixed axis. Now in Simscape multibody, the reference frame is required to be an inertial frame, and this word or this terminology comes from Newton's laws. We don't need to go deep into what's meant by this word, just knowing that it's a point which is at absolute rest is sufficient for our work, and moderate light to moderate work as well. That and there's another block called mechanism configuration. We didn't see a similar block in previous cases, so this is kind of new. This mainly serves two functions. One is to specify the gravity, and other has to do with specifying a model linearization parameter. This model linearization parameter is once again something we leave at a default values, but is also something that you should know. E is something that can be changed if you want to at some point. So we'll just use it to specify the gravity, and we'll see how to do it later on. So this is my strategy, and this is what's actually recommended by Simulink in its template models, is to connect these three together and make the connection between the network to somewhere in this network, in the network of these three, in order for you to connect them. Right. So I think it's quite evident that bodies consist of geometries and information regarding the inertia of that geometry, in addition to the origin block and its coordinate system of a body. So there are multiple types of blocks that you can bring in to the canvas, uh, and double click and parameterize in order for you to generate the geometry that you want. It's kind of a very arduous task, but Simscape Multibody also allows you to import bodies from other CAD format as well, whether it's SolidWorks, Inventor, OnShape, or whatever it is, or in neutral forms such as Step or STL. Geometry can be imported, and upon specifying the density, the mass will be calculated. And another quite useful feature for Simscape Multibody is that upon importing the geometry, the mass can be specified, and we can ask Simscape to calculate what the density is, and it will assume a uniform mass distribution and calculate the inertia. Kind of a reverse calculation of what we usually do, but it's kind of an important feature, and we'll be using this to be specifying a geometry and the mass.